Hi class, today we'll be talking about complex experimental designs. And as I had mentioned, this chapter is a little bit more complicated than the previous chapters that we've looked at, but we'll do our best to kind of go through it step by step. And then of course, we'll be talking about this during our class. So when you're thinking about experimental designs, there might be an experiment in which you want to take a look at more than one independent variable. So far, we've been only talking about study designs that have one independent variable with multiple levels, but I might actually want to take a look at more than one. Now, I could either run a bunch of different studies, each with an independent variable, or I can run one study with multiple independent variables. And this actually is much more efficient for us as researchers, and it actually can produce really unique pieces of information. So we can actually look at the relationship between both of our independent variables together because now they're in the same study. So a factorial design is a design with more than one independent variable or factor. Now the simplest factorial design is going to be a 2 by 2 factorial design. Each of these numbers here that you see, this 2 and this 2, this value stands for one independent variable. This value stands for another independent variable. The 2 then tells us how many different levels of each independent variable that we have. So here we have 2 independent variables, each with 2 levels within that independent variable, right? So this is what the number tells you, the number of, so if we had a 2 by 2 by 3, that would mean that we have 3 independent variables. The first one has 2 levels, the second one has 2 levels, and the third independent variable would have 3 levels, right? So that's what the numbers stand for. And this will be important for you when you're kind of discerning the number of independent variables you have in your research study. I want to show you very quickly a really great YouTube video that shows you how to calculate and look at these independent variables. And then we'll go through and take a look at a study together. So let's go ahead and flip over to our YouTube video and put that right here. And as I pointed out and as I mentioned to you, this is a really great video. It gives us a really good idea of how we would calculate and look at these independent variables together and use them and look at them all in one place. So let's go ahead and take a look at this video.
Designs, a little bit more complex design, and I will try, as I did in the last one, to give you an interesting topic on which to do this. I use pictures, and I manipulated them a little bit. In this case, as you can see, I've got a picture of me in the upper left side, and then using the magic of hair mixer, I put a little hair in myself. And so what I did was I played around with the idea that one of these guys is attractive and one of them is ordinary. How this hair color affected our perceptions. We know that attractive people are afforded all kinds of advantages in our society. However, did you know there are some situations in which being attractive actually works to your disadvantage? And the situation I'm going to look at is this. If you are accused of a crime, okay, so here's one of my upcoming independent variables, type of crime. If you're accused of a crime, not surprisingly, attractive people tend to get lower sentences. So let's take a look at that. I'm going to move things around a little bit because I'm going to look at another thing. All right, so yes, I'm going to look at attractiveness, and we've got the ordinary guy here. Now I'm going to move this around because I'm going to create a new design here. And here's the attractive guy. So attractive people, lower length of sentences, unless they use their attractiveness in the committing of the crime. So, for example, if you, instead of a typical crime, which we'll use a robbery, what if the crime was a swindle? In other words, you are a man in this case, let's say, and you swindle a somewhat older woman, let's say, out of her money by pretending to like her. Now, in that case, if you are attractive, you will get a longer sentence as a result, right? Because you used your attractiveness, and that's where we sort of, there's also, of course, a certain hidden envy about people who are attractive, and so when we have a chance, sort of tied into how we like to see the mighty fall, right? Where that kind of thing, which I'm sure you're familiar with as well. So if you're attractive, so what I'm going to do, I'm going to make a copy of Mr. Attractive here. Actually, I think I called him Mr. Swarmy in the previous episode, but whatever. So now I have a 4-condition experiment. All right. So I'm going to bring subjects in, give them.
Okay, so I just want to stop us really quickly before we get too far along. And you see at the top here, this type of crime, that would be one independent variable. And we have 2 different levels of that independent variable, whether it's a robbery or a swindle. On the other side, we have attractiveness of the criminal. This also is an independent variable, and it has 2 levels, ordinary or attractive. So you can see here that if I were to do a study, I could do a study where I just simply look at the attractiveness of a criminal, right? And looked at sentencing that they received. Or I could look at type of crime a person committed, whether it was a robbery or swindle, and see if there's a difference in the amount of time that they served. Now remember, if I did it this way, I would actually have to do 2 completely separate research studies. But I can actually combine them together, and this is why I have independent variable 1 and independent variable 2. So my factorial design would be a 2 by 2 factorial design. And now I can take a look at my independent variable in one aspect, so type of crime. And I can also look at my independent variable for attractiveness of the criminal. But this is where it gets really interesting. I can combine each of these independent variables together and see how they might influence each other. So does an ordinary person who commits a robbery get a different sentence than an ordinary person who commits a swindle? So now I can combine each of my independent variables together. So now I'm getting multiple pieces of information, right? I can look at the effects of my attractiveness of the criminal on the amount of time I serve in prison. I can look at the type of crime a person commits and the amount of time that they serve. And then I can look at the relationship of these 2 things together. Okay, so let's get back to that video then.
Them a picture to look at of a person who committed a crime. And this is a between subjects design, so you don't know that there are 4 conditions and 2 different looking people. You just come in, you see one picture, you read about the crime that person committed, and then I asked you to assign a sentence. How long should this person spend in jail? And probably I give you some guidelines because young students may not know what is typical. But within there, I'm sure I'm going to allow students to plenty of room to decide on the length of the sentence. So it's getting a little bit more complicated, I suppose, than the previous design, because there are all kinds of possibilities here. So I'm going to give you some possible outcomes for each of these conditions. And again, that is the dependent variable is the length of the sentence as measured in months. Okay. So I'll get rid of that. Here's some hypothetical results. Here we have it for condition number 1, up upper left. Okay, ordinary looking guy commits a robbery. I'm going to say that they're going to, my hypothetical subjects are going to give this person 5.1 on average months in jail. Okay, and hopefully I've got a good number in there, 20, 30 students, optimally, somewhere in there. So I've got 30 times 4, I've got 120 subjects. So already you can see a factorial design is going to require more subjects to do. Okay, so here's the other situation, top right. Ordinary looking guy, but he commits a swindle. And so now I'm going to say that the subjects are going to give, on average, a little higher number of months in prison, 6.4 months. Okay, interesting. I say that because probably swindles, people would sympathize with someone being victimized, maybe in a robbery. It depends upon the description. In the robbery, it may be possible for the person to get back what was lost through insurance, but a swindle is a little bit more of a painful crime. So we'll say that probably the number of months in jail is a little higher.
Okay, so let's keep on going. I'm sorry.
Okay, so that's what happens here for Mr. Ordinary. All right? Now what happens for Mr. Attractive? Well, let's go with robbery. Now, if it's a robbery, I've said before that being attractive works in your favor, and so I'm going to say, if previous research supports me, that subjects would give an attractive guy a less amount of time in jail. So I'm going to give them a mean of 2.2 months, and that would go along with the research, as I say. However, again, if the research is right, it's going to look like this. If you lower right-hand corner, attractive guy who commits a swindle. Now I think the subjects are going to get out there, some of that attractiveness, envy, and I think that they are going to give that person a longer amount, the longest amount of time in jail, 10 and a half months. All right, so more conditions. We got more data here. Now, how do you analyze this? I mean, because I've described it as we've gone along, but if you were to just look at this, you might not say, oh, it's obvious what's going on here. And as we get more subjects and more conditions, it does become less obvious what's going on. Now, this, by the way, is a 2 by 2 factorial design, right? And that's pretty straightforward. There are 2 independent variables, 2 conditions, 2 levels of each. I could look at a third thing. For example, these are all pictures of myself. These are obviously the gender here is male. What if I were to take these 4 conditions and reproduce them another time here? Take all 4 of these. What if we looked at gender? So does this same pattern occur if the robber or the swindler is female? Or is it even stronger? I mean, what are the reactions of subjects to a description of a crime and attractiveness if the robber, swindler, is female? If I were to do that, I would have a 2 by 2 by 2 factorial design, and that's when things really get complicated, and that's when you've got to put things on a graph, which we'll do in just a minute. First, just to show you a little bit of the analysis that goes on here, one thing I would do is I would average across one of the independent variables here, that of attractiveness of the criminal. All right. So if I smash together the robbery and the swindle, in other words, I average 5.1 and 6.4, I'd get an average of 5.8 months in prison. And then if I smash together these 2, and I just looked at attractiveness, and it would be kind of funny, right? Because I would average together 2.2 and 10.5, and I'd get an average of 6.4, which if you look at that, and by the way, this is called the main effect of attractiveness. If I looked at these averages and I forgot about crime, or type of crime for a minute, 5.8, 6.4. I mean, it looks almost like attractive people get more time in jail. Although 6.4 is not that much higher than 5.8, it almost looks like, if you look at this data, that there's no difference. That attractive people are not afforded less time, right, in jail. So that's kind of funny. If you look at that sort of data from just that one main effect.
Okay, so kind of looking at this, let's just back up just a little bit because I want to show you something here. So remember when we said that we could look at each of the independent variables on its own as if it was its own study? If we were to look at the attractiveness of a criminal and how it related to our dependent variable, which is amount of time in jail, right, or amount of sentence that people think a person should have in jail, this would be here what we're looking at, a main effect, right? So these averages right here is actually the average of the attractiveness of the criminal, which is one of our independent variables. We're going to do the exact same thing here, again, by looking at type of crime, which would also be an independent variable, and we would average down instead of across. So you would take robbery and swindle, you would add 5.1 plus 2.2, and then divide that number by 2. And that's what he's saying when you'll get the average. So you'll get an average score here. Same thing, 6.4 plus 10.5, and then we're going to divide that by 2, and we will get an average of the swindle, right? And this will be our main effect for type of crime. So now we're taking a look not only at the relationship between what the type of crime is and the attractiveness of the individual, but we're also taking a look at the main effect, which are the independent variables on their own. So let's go back to our video quickly.
If you look at that sort of data from just that one main effect. All right, but let me move this back. There we go. But we can do the same thing with the attractiveness. We can sort of collapse across that. If I average 5.1 under robbery and 2.2, these two groups, in other words, 30 subjects here and 30 here, I would get a mean of 3.7. And if I did the same thing on these two columns on the right, swindle, swindle ordinary and swindle attractive, get a mean of 8.5. Now I'm looking at what's called the main effect for crime. So these outside means are called main effects. And here it becomes clear that swindlers get more time in jail than do robbers, or just robbers. Okay, so is that what's going on? Or is there something more subtle going on? Does it look like simply that if you swindle, you get more time in jail than if you just do a robbery, but if you're attractive or not, it doesn't really matter? Well, that's what it sort of looks like if you look at it this way. But if you were to plot the data, and of course, you would have to perform an analysis of variance. Okay, and that would be your statistical technique. Hang in there. We get to the interesting part here, although I guess I've already given it away. This would be hypothetical results. All right, effect of attractiveness and type of crime on length of sentence. That's my lengthy scientific sounding title. On the bottom is one of the independent variables. In this case, I'll go with type of crime, robbery and swindle. Over here we always put the dependent variable on the left y-axis. And as you can see, what this suggests is that if it's a robbery, the bluish here are ordinary looking people. If it's a robbery, then ordinary people get longer sentences than attractive people, the red. But if it's a swindle, then the attractive people spend a longer time in jail. And it's actually better. One of the things that you'll learn in doing research is that if the lines cross, so if I were to do this exact same thing as a line graph, it would look like this. And, excuse me, Any crossing lines indicate a significant interaction. Well, an interaction, the analysis of variance would tell you whether or not it was significant. All right, so that's the story. We get a little bit more complicated here, but as usual, psychologists do the most fun research. At least that's what I think. Okay, so there you go. That's episode 52 of the Psych Files.
All right. So let's kind of go back here and walk through that back part of the chart, how he got that. So what we're doing here is we're trying to see if there is an interaction between each of our independent variables. We cannot see that from just the averages. We actually have to plot that on a graph and take a look at whether or not the lines intersect. So where do you get those points from? You have to come back to your chart that's here, right? Or your table rather, that's here. So we would take our averages that are here, and then we would go back and we would plot them on and make a bar graph. Okay, so you're taking the averages from here. So we're going to plot on our graph the type of crime, and actually in this case we're going to say our y-axis is always your dependent variable. So we're going to put our dependent variable here, which is the length of our sentence, and then you pick one of the independent variables to plot here, and then you will make each of your bar graphs by your other independent variable. So here we have our type of crime as one of our independent variables, right? So this is our type of crime as one of our independent variables. And then we're going to plot it by the attractiveness of our criminal, which is our second independent variable, okay? So if we have a robbery that's done by an ordinary looking person, the average is about 5.1. So if we have a robbery done by an ordinary person, we would go here, and this is probably about 5.1. So this is where we would get this blue graph. Okay, let's go back to our chart. Then we have a ordinary person who commits a swindle, and they get about 6.4. So we go back over here. Our ordinary person, now this is the different type of crime, right? So we take an ordinary person who does a swindle, and we got that 6.4, right? So our 6.4 here, we draw that out. Now let's go and take a look at our attractive person. Let's see what that would look like. So our attractive person that commits a robbery is about a 2.2. We go over here. We say, all right, I'm an attractive person. I commit a robbery. I get about 2.2 years in prison, or months in prison. We go back and we see our attractive person in a swindle. They get about 10.5. So we go back over here. Whoop. And we'll plot that. So we have a swindler who is attractive. How long? Okay, about 10.5. So we plot that here. So this is where we're getting each of those numbers. But now is where we see if there's a relationship between each of our independent variables. And this is known as an interaction. So what I would suggest you do is you make a little dot here and a little dot here, and you connect that line. And then you make a little dot here, and you make a little dot here, and you connect that line. And when you do that, you end up getting something that looks like this. You connect those lines. If those lines intersect at any point, then you have an interaction between each of your independent variables. Now, this is unique. We would not have been able to see if there was this interaction if we had done each of our independent variables separately as a study. So this is where we're getting that extra piece of information. So going back, type of crime is one independent variable. We add, right, and divide to get our averages. This is the main effect for crime. It's as if we were looking at the type of crime as its own study and looking at the amount of time that was served, right? Same thing if we looked at attractiveness of a criminal. That is another independent variable. We take a look at this and we add and then average across, right? 5.1 plus 6.4 divided by 2. This gives us an average. So now we've got these two different averages, and this is our main effect of attractiveness of a criminal. So how do we know if we have a main effect? We have to look at the difference between these numbers. So in this case, these numbers are significantly, we would say they're pretty different. So we would say there is a main effect for crime. If we were to look at this, they seem to be pretty similar. So we might not think that there's a main effect for attractiveness. But when we plot these numbers onto our bar graph and then subsequently try to connect those lines, now we can see that there's an interaction between each of our independent variables. So this is how we would take a look at our factorial designs, our complex experimental designs. So let's take you back to our PowerPoint. I want to now go over with you one additional study. All right, so this is in your textbook, so you can follow along there. Here, we're going to do another 2x2 factorial design. So again, the 2 and the 2 indicate how many levels of our independent variable. The number of different numbers we have in our equation tells us how many independent variables, right? So we have 2 independent variables, each with 2 levels. That's what our 2x2 factorial design means. Okay, so we want to do a study and we want to take a look at the modeling of food intake. So if we see somebody else eating, will that influence how we then eat? So in our experiment, our subject is going to be paired with a confederate who's of the same sex as them, and they're going to view and rate movie trailers. So they're either going to be seated in a comfortable living room with a bowl of M&Ms, and then after 10 minutes of viewing, there's going to be a break. Now we've got our 2 independent variables. The first is how social our confederate is. Are they chit-chatty with us? Do they talk to us? The second independent variable is going to be how much food does that confederate consume, right? So remember, each of these could actually be its own study. We could do a study where we looked at how social a person is and how much you ate. We could also do another study looking at how much somebody's eating nearby to you and how much that influences the food consumption that you have. Each of these could be its own study, but we want to take a look at this together, right? So we can also take a look if there's a relationship between how social a confederate is and also how much food that they eat in front of you. Will that influence how much food then you eat, right? So this will be taking a look to see if there's an interaction, but we're getting a little ahead of ourselves. So the social confederate is going to initiate some conversation. The unsocial confederate is not. They're only going to respond with very brief answers. The confederate is always going to be the first one to reach for the M&Ms. In our low food intake condition, confederate is only taking 1 piece of candy. In the low food condition, a total of 6 pieces are going to be taken during the break. In the high food intake condition, 4 pieces are going to be taken immediately, and then 24 pieces are going to be taken over the course, over that break. So what does the design look like? We've got a 2x2 design. What are my independent variables then? We've got our confederate sociability, and then our Confederate food intake. So the first has 2 levels, social versus unsocial. The second independent variable also has 2 levels, right? This is indicated by my number here. High food intake or low food intake. So when we have a 2x2 design, remember this, a 2x2 design will always have 4 groups. So what are our groups going to be then? We have a social Confederate modeling low food intake, an unsocial Confederate monitoring a low food intake, a social Confederate who is going to be engaging in that high food intake, and then we have our unsocial Confederate who will be modeling that high food intake, right? So if we take a look at that here, and then we're going to first put it into a table, we have independent variable A in one side, and then we're going to have independent variable B on our other side. So here we've got our Confederate sociability, and then on this side we have our Confederate food intake, right? Low or high. Here having a social person or an unsocial person. And then this is where we get each of our groups, right? A social person who is modeled with low food intake, social person with high, unsocial person with low, unsocial person with high. Okay, so remember, when we get our values, we are going to add an average, right? So add and then divide by 2 to get an average here. When we look down, this will be our main effect for our independent variable A, which is going to be how social our Confederate is. We're going to do the same thing across, where we add these 2 columns, divide by 2 to get an average, and then when we do it this way, it is our main effect by the Confederate food intake, right? Whether they model high or low. We will then go ahead and plot those values from our table here, and then we will see if they overlap. If they do, we have an interaction. That means that there's a relationship between each of our independent variables. So our factorial design is going to yield 2 kinds of information. As we talked about, we're going to look at main effects, right? And there should be a main effect that we note for each independent variable. So in this case, we're going to have 2 different main effects. If there is an interaction between the independent variable, we'll be able to see this on our graph by kind of plotting that as a bar graph and then turning that into a line graph and seeing if those lines overlap or intersect. When you get into statistics, this analysis is actually called an ANOVA, or an analysis of variance. So when you learn an ANOVA, you are actually learning what we are plotting here today. You'll be able to put this into your statistical software. You'll be able to calculate that out, and you'll be doing that through actually that program. So this, as an analysis, is called an ANOVA. All right, so here we go. When we have a social participant who models kind of low intake, the person on average eats about 6.5, or participant eats about 6.5 M&Ms. If they are part of that unsocial condition, right? They have the unsocial Confederate who doesn't eat a lot. They eat about 2.14 pieces of candy or M&Ms. When they are in they have a social Confederate, right? The social person's watching that movie with them, and they're eating a lot of food. They are having about 5.68 pieces of M&Ms or candy. When they're in an unsocial Confederate in a high food intake, they eat 10.63 pieces of candy. So it almost seems like, right? What is this sort of telling us? Well, let's take a look at the main effect. So let's see if there's a difference in how much food our Confederate eats, either high or low. So in order to do that, we have to add 6.58 plus 2.14, and then we divide by 2. That gives us 4.36. We do the same thing across. 5.68 plus 10.63, that gives us 8.16. These numbers are quite different from each other. So we would say that there is a main effect by Confederate food intake. Okay, so that seems to influence us. When we plot and take a look at it down this way, we see our Confederate sociability. So we take 6.58 plus 5.68, we divide by 2, we get 6.13. Then we take 2.14 plus 10.63, we get 6.39. If we're looking at it this way, we would probably not say that there is a main effect by how social our Confederate is. But we would say that there's a main effect by how much food that our Confederate eats, right? Because these numbers are quite different from each other. Okay, so now we want to see if there's going to be an interaction between our independent variables. So we plot this. Now remember, we are going to get these numbers from our chart. So our y-axis is always going to be our dependent variable. In this case, this is the number of M&Ms consumed. We then take one of our independent variables, we plot it here, so our social versus our unsocial Confederate, and then we take a look at it in terms of differences of groups between low food intake and high food intake. Again, in order to get those values, we have to go to this table. So we see, I'm just going to do one so you can kind of take a look and follow along. So we have our social Confederate in the low food intake at 6.58. So we have our social Confederate low food intake, we plot that, 6.58. That's how we get this bar graph. We'll do the same for each of the other bars. But we need to find out if there's an interaction. So remember, the way we do that is we'll take a little, we'll put a little dot here and a little dot here, and then we'll connect those lines. So we'll do something like this. We'll do the same on this bar graph. We'll put a little dot here and a little dot here, and then we're going to connect those lines. And what we see is that that they're interacting with each other, right? That they overlap, they intersect. Again, if at any point in time they intersect, we would say that there is an interaction between each of our independent variables, okay? So this kind of leaves us with some of the key terms that we have for this chapter. Again, when we meet in class, we'll be able to go through some of this in greater detail. So please do come prepared with all of your questions. So that way we can really dive in and I can help answer anything that you might be having problems with. All right. So with that, we'll go ahead and end this chapter, and I will see you all in class. All right. Have a good one.